Unit 10, Lesson 3, I can recognize the relationship of two secants or tangents and calculate the angle or arc. Let's go over the new vocab real quick. What is a secant? A secant looks like this. Touches the circle twice, and it's a line that goes through. Line that intersects the circle exactly twice. Let's compare that to a chord. This was a chord. It's not a line, but it's a segment with endpoints on the circle. So that's a chord, that's a secant. A tangent is a line, but notice how it touches exactly once. That's the difference here compared to the twice up here. So today we're going to focus on where two lines or segments intersect with a circle and the relationship with the angles that they create. So we're going to deal with tangents and secants in particular. So we're actually going to pull a few lessons together at the same time as we explore this. So we have all these different kind of situations that are going to make up today's presentation, and by comparing to prior lesson knowledge, hopefully we can put it all together and tell everything apart. So let's go ahead for a second and make sure we can just name each of the things we're seeing. These are two secants because they touch exactly twice. This is a secant and a tangent. Okay, so these are two secants. This is a secant. This is a tangent. Again, two secants, two secants. Make sure we can identify those things. And the most important thing is figuring out where these lines or segments intersect each other. Where do they intersect is the key. And you'll notice, for example, that here they intersect, and we're going to start this example here. They intersect here. Is it in, out, or on the circle? And this one is clearly on the circle, which we know is an inscribed angle. So they're on the circle. And when that happens, what's the relationship? Well, the measure of your angle is equal to the arc, however, divided by 2. Okay, so let's go ahead and look at the next one. Where are the secant and the tangent intersecting? Still on the circle. It looks a little odd, but it is on. So it's still an inscribed angle. I use the vocab as much as I can to help me remember it. So it's still on, so it's still that the measure of the angle is equal to that arc divided by 2. Let's make up some numbers just to prove this to ourselves real quickly. So for example, if I turn the light of this inscribed angle on, it intercepts this arc. So if this up here happened to be 80 degrees, what's the measure of this inscribed angle? Well, the arc is 80. 80 divided by 2 is just 40. The reverse is true. If I told you this is 40, you know this is half of what this arc is up here. So double this, you get 80. While it looks odd over here, this is the angle that I'm talking about that sits on the circle, the inscribed angle. The arc that its light intercepts is that right there. So, for example, if this arc here were 200 degrees, what's the measure of this angle? Half, 100. Or if I told you this is 100, you know this would be 200. Works both ways. We can get a little more fancy and say, well, what happens if we weren't talking about that angle? What about this inscribed angle over here? If you turn its light on, what actually would hit this arc? That's its intercepted arc. There's a lot of ways to go at this. You know the entire circle is 360. This is 200. Then it's another 160 over here to make 360. Or maybe you're saying these are a linear pair, so this has to be 80. These are all good ways to think about it. And notice this is half of the intercepted arc because it's an inscribed angle. So that's what we learned in the first lesson in this unit. And these are two different instances in how it will show up, made by secants or a tangent and a secant. And we want to be clear we can understand how to find the measure of either the arc or the angle. Let's look at the next thing we learned. Where are these two secants intercepting each other? There they are. They're intersecting each other right there inside the circle. They're not central angles. They're not on the center. They're just intercepting each other in the circle, not on like an inscribed angle. So what's the relationship there? We talked about how the measure of the angle here is equal to arc 1 plus arc 2 over 2. Sometimes people like to think of it as the large plus the small over 2, and it doesn't really matter the order in which you do them. So I can say, for example, if I turn on this angle here and this angle here, this would be perhaps the small and that would be the large. Here's my small, here's my large, and this is my angle that I'm talking about in there. I could do the same thing with this arc, and these angles here. Okay, and then if we come back to this new version, where are the two secants intersecting? And it turns out they're intersecting here. This is outside the circle. This was inside the circle. Well, what's the relationship? And instead of doing a bunch of examples to look for a pattern with some inductive reasoning, we're going to go straight to this with some direct explanation and say that the relationship here is exactly the same as this one over here. Except when you're outside the circle, there's one change. This plus turns into a minus. So let me explain what that looks like. This angle, our angle now, is this little one right here. It's the same thing as the one out here because of vertical angles. But if you shine the light, it intercepts this arc. And the light is so powerful, it keeps going through and catches that arc. Okay, follow the beam of light between the two rays of the angle. And I would call this my small, I would call this my large arc. Okay, again, this is outside the circle. And the relationship is that the measure of the angle just happens to be equal to the large arc minus the small arc over 2. And that is the key here. We're going with subtraction. It's the new piece for today's lesson. How do you remember the difference? Well, you can remember when the vertex is on the circle that it's half the intercepted arc. You remember when the vertex is at the center, it's just the same. But how do you tell the difference between these two? There's the phrase being in the loop. And if you're in the loop, you're being kept in the know. People are telling you what's going on. So if the intersection is inside the loop, the circle, it's a positive thing. You're being told what's up. You're in the know. So if you're in the loop, it's a positive thing. It's a plus. But if you're outside the loop, people are cutting you out of the loop. You don't know what's going on. And that's a negative thing. So it's a minus. And that's the way I had kept them straight. And you can come up with your own way. Now let's go and try and apply these. I'm going to go ahead and solve 4 problems really quickly. You can press pause at any time to try them on your own, and then press play to see if my solution matches yours. Don't forget to find your find and to annotate. I'm looking for x. Okay, here I go. I'm looking for x. This angle here, if I turn this light on, intercepts this arc. You can already see the vertex is on the circle. This is an inscribed angle, so the measure of the angle is equal to half of the arc. So my angle is called x, but I don't know how long this is right here. And sometimes I get tricky, and you have to know another relationship, which is the full circle is 360. So I have 140 over here, 170 over here. So basically, the relationship is 140 plus the 170 plus my question mark is equal to 360. That I just have to realize. This plus this plus this is 360. So if you combine like terms here, I think you get 310 plus the question mark is 360. And if I take 310 from both sides, the missing arc measure is 50. So this becomes 50 degrees. So I was sneaky, and I needed you to realize that 360 is the full measurement of a circle's arc. So once you got that, this is 50, no problem, over 2. You're looking at 25 for x. Let's go take a look at the next one. We're looking for x is our find. Where is the vertex? The vertex is still on the circle, so it's still inscribed. So the measure of that angle is still equal to the arc divided by 2. So my angle happens to be 50. Make sure you substitute properly. The arc is x, split over 2. How do I solve? Multiply both sides by 2. Your x is 100 degrees. Those are the inscribed angle examples. This one tends to be the most confusing because it looks odd with the way it's set up, but it is just inscribed. Let's go look at the next two. Okay, these two secants are intersecting each other inside the circle, and being in the loop is a positive thing. So the measure of the angle is equal to the large plus the small arcs over 2. So you just go ahead and substitute and work your magic. 2x is the angle. Make sure things go in the right spots. Just to be super clear, go ahead. This is the angle I'm working with. It intercepts this arc here and this arc here. 60 perhaps goes there, a little larger, 2x minus 10. Over there, we're adding them up, all over 2. Don't start crossing out these 2's. Tempting, don't do it. Combine all your like terms. 60 and negative 10 is 50, plus 2x, all over 2. You have options here. I think it's easier probably just to multiply both sides by 2, but you could actually split this up and make it 50 over 2 and 2x over 2. There's a lot of ways to do this. And reduce, I'm just going to multiply both sides by 2 to undo the division. 2 times 2x is 4x. So now I have 4x is equal to 50 plus 2x. And it's just algebra. Take 2x's from both sides. And you're looking at 2x equals 50, or x is equal to 25. Last one. You can try it on your own if you like. I'm solving for x is my find. I'm looking for this angle. If I turn its light on, it intercepts this arc here and this one over here, which is kind of confusing because it looks like I just did the whole circle. And it's because I did. This would be the small arc, this would be the large arc, and I already know the relationship is that the measure of the angle is equal to the large minus the small arcs over 2. Okay, well I see x goes here for the angle, and I see my small is 150. But what's my large? I don't know what to put in for that right there. And it goes back to that sneaky relationship. How much is a whole circle? 360. So if you go and you do 360 minus the 150, you get 210. So 210 is the rest of this out here, because this and this make 360 together. These are tangents because they're each touching once. So I can go ahead and put 210 here. A little tricky there. Go ahead and do the difference. You're going to get x is equal to 60 over 2, or x is equal to 30. So the key, find your find, annotate where the intersection is. Is it outside the circle? Being out of the loop is a negative thing, so it's going to be the minus relationship? Is it inside the circle, or it's going to be a plus relationship? Or is it on the circle in one of these ways where the angle is equal to half the arc? Annotate and you'll be fine. Good luck.